Hello, and welcome to today's webinar. Can AI be applied to ITS, Traffic Management and Planning 2.0? Part of the Connect Me Asset Mapping series of harnessing location intelligence. My name's Aaron Addison, and I'm the Executive Director of the World Geospatial Industry Council, or WGIC. We're a global nonprofit trade association for geospatial and Earth observation companies, and I'll be moderating the event and hosting the Q&A later in the presentation. Before we get started, we'd like to run a quick poll of the audience to find out where you're from and what industries and sectors you work in. The poll will pop up on your screen momentarily, so please be sure to fill it in and hit submit. Before we get started, we have a few housekeeping things to also go over. We always like to have an interactive webinar, so please enter your questions into the Q&A space located on the bottom navigation bar of your screen. There's no need to raise your hand. Just post all questions in the Q&A space. Presenters will respond to all questions at the end of all the presentations in a panel discussion session. Also, please be sure to participate in any audience polls as they may pop up during the sessions. For information about our speakers and event agenda, click the Resources tab at the bottom of your screen. We've also shared some useful links in the Resources section, which you can click and access at any time. This session is being recorded and will be available for download on demand after the event. You'll receive an email notifying you when the recording is available. We'd like to thank our webinar sponsors for today, TomTom, for making this educational opportunity available to you. Besides myself, today we're joined by two speakers, Kristina Vuletic, Senior Product Manager for TomTom, and Brent Rogerson, Director, Solutions Engineering at Miovision. With that, I will step back and invite Kristina to join the stage and begin our webinar. Thank you.
All right. Hi, everyone. Good morning, afternoon, and evening, especially for me. Let me just get my screen share going over here. And I will get started. Okay, I hope everyone can see that one. Thanks a lot for joining us today on this lovely Tuesday for the topic, Can AI be applied in ITS? And I'm going to talk to you all from the product perspective at TomTom. So just to roll through what I'll talk about today for the next sort of 15 to 20 minutes, let's take a look at who TomTom is and what role we play in this question, in the solution to the question. I'll take you through what we're thinking and how we think in terms of the future of AI in location analytics. And then I will share a little video demo of the first TomTom AI agent for location analytics, which is pretty exciting for us. And then after my presentation, I'll hand over to Brent from Miovision to take you through some more really exciting stuff from their side. Slowly my internet goes. Right, but first, I'm Kristina Vuletic, based in the TomTom office in Madrid. I'm the lead product manager for the location analytics product suite here at TomTom. I'm a product manager with about 10 years of experience across SaaS, e-commerce, and now, of course, location technology industry. So, TomTom, yes, we've been around for a while and we are still around. Remember us from the personal navigation device that you may have at home. You may have 5 at home in a drawer, like my family does. So we are still TomTom, and what we're doing, the thing that we do at our core is we make maps that impact everyone, everywhere. We're a global company, and we're building a new generation of maps on a universal standard that integrates open data. And what this is doing is building a platform that enables automakers, they're our big customers, but also businesses, insurers, and specifically here for today, governments, cities, smart cities, to develop and solve their most challenging mobility problems and use cases. So what does that look like? It looks like a lot of cool little dots on a map. So this is basically how we think about building a map. We have the underlying base map and a lot of layers on top of that. And what you can see here is a little representation of the data that is coming back into us from our automotive customers, our enterprise customers, and then these moving blue dots are actual devices. And then building that up, what you can see here is traffic, so and speeds. So what you can see is sort of like the boxes going up here are speeds. And you can, of course, see different layers, which are 3D layers, transport layers. Oh, my poor video stopped. Apologies if it stopped for you. And then other map layers. So that's a little bit of what it looks like on the back end. So this all collaborates into a pretty extensive location technology product suite. Of course, at the very center of it is the TomTom map, a unified mapping solution, open, flexible, built for automotive and business customers. That's probably what we're most known for. We have an extremely competitive traffic service, like both live and historical, built using the data that is coming back from the devices that are connected to our traffic service and to our mapping service as well. We've got hundreds of millions of devices that are feeding back that information that helps us build my product suite, which is location analytics. We have, of course, very interesting maps for automation and autonomous driving. So centimeter level accuracy, very interesting for autonomous driving, but also can get very interesting when we look at analytics. We have, of course, EV data services, hugely interesting at the moment. And finally, an SDK, which helps other companies build their own bespoke solutions on top of the array of data that we have. So just a little bit sort of under the hood, since we're speaking about AI, these are a few ways we're helping, we're enabling, or at least using AI in the behind the scenes at TomTom to help us build better maps and better traffic. So of course it helps us enrich map data at scale. We have a huge global map, extraordinarily fresh and as accurate as possible, world leading. What we do is we use a lot of sensor-derived observations to build that map, GPS traces, aerial imagery, and survey vehicles, of course, still exist to build the world's best map. And of course, we can't do that without some of the AI technologies coming through ML tech as well to help us build that. Of course, it's excellent for recognizing signs, so we give the end customer the right information. We can also use this information in my space to analyze different types of things that we see or any sort of interesting aspects of the road, for example, like stop signs, and comparing these with other things that are going on, maybe to influence if the road is safe or not, what's happening in that context. Of course, it's very important, especially with our very high definition map, that AI starts to learn, or at least some of our algorithms are starting to learn how real traffic moves through an intersection, if they're sort of tending left or right, or where people are really driving. And AI is, of course, enabling this. And this is, again, very interesting to start analyzing in a location analytics product suite. So finally, let's have a discussion about what we're thinking from the location analytics perspective in terms of AI and how we're enabling both ourselves internally and our partners like Miovision to build better products, build better insights with the vast array of data that we have. So what my product suite or location analytics product suite is doing right now this year is really trying to combine using AI and then being able to access that data by AI. So combining map data, so our very highly diverse set of map data with our extremely competitive live and historical traffic data. And it's not only traffic data, it's also traffic signals, incidents, weather, hazards, speed cameras, any other type of mobility or dynamic data that we have What we're doing right now is building more insights using that data and then serving them directly to our customer at the moment, but also to AI systems or different services like Miovision are using to build their end products. So how do we do that, or at least what's the value behind it, behind all of these data insights? It's our huge coverage and hundreds of millions of devices that are contributing mainly in our location analytics product suite, GPS trace data, very high fidelity because of our relationship with automakers, very automotive driven fleet that we have, and we do a serious number of kilometers driven every day. And what we do, my product suite does with this is we align this with the map and all of our other different data types and start to build insights out of that data and then serve them to our customers. For example, this is how we think about building our live traffic product. It's, of course, not just GPS probe data, but we do a lot of other stuff, journalistic data, sensor-derived observations. A lot of active community input goes into our live traffic moderation, and a pretty significant amount of historical data goes into our Fusion engine, and we're piping out every 30 seconds our traffic flow and our traffic incident product, updating it every 30 seconds globally. That's going down directly to our automotive customers, it's going to our enterprise customers, and of course it's coming to the location analytics product suite, and where we can start to do some cool analytics on top of this data, and of course serve that down to AI systems as well in the future. So where does this start to make sense for us in terms of the use case of of traffic management? I think really operations, planning, and safety are our key focus areas where TomTom and location analytics want to help our partners get better insights down to their end customers. So of course, in terms of management and operations, we have very, very strong real-time traffic information and a few other products that I'll go through in a second. We've got great incident detection, things like road closures, roadworks, and of course updated every 30 seconds. Secondly, we can think about this in terms of planning and optimization, especially with our pretty large data set of historical mobility data. We can look at travel time, we can look at origin destinations, we can think about event management with this information, looking at historical data, and of course, construction and maintenance as well, and planning. Finally, we're starting to get more involved in the safety side of traffic intelligence, so bring in some of those additional data points related to safety, weather, sensor-derived observations, accidents, incidents, closures, things like that, bringing those things all together, speed, volume, and looking at that from a holistic perspective. So that's where our data really can play already really well. And this is quite interesting when we think about what AI does on top of that. So I'll just take you through our most well-recognized historical or traffic analytics, location analytics products. It's called the Move product suite. Some of you will be very well used to the Move product suite already. Some of this will be new. So we have, of course, traffic stats and origin destination analysis. So very deep speed and travel time information from traffic stats globally, anywhere in the world. Back more than 10 years worth of data in most places where we have coverage. So very interesting for a lot of customers, but we do have very long running history of speeds and volumes. Origin destination analysis, of course, looking at trip patterns through an area, different types of areas, and of course, segments. We have two live products here as well. Route monitoring does what it says on the tin, excellent for messaging signs and utilizing our extremely competitive real-time traffic data. and junction analytics. This is something that Brent might talk about a little bit more, which is really understanding movements, turn movements through a junction without the need for any hardware. With junction analytics, you can analyze any junction in our coverage area. In about 2 minutes, you can start reading real-time data. So really cool and exciting product. And you'll see a bit from Miovision how cool that's getting with our partners. So yes, what do we help with in this case with all of this data? We can do things like congestion analysis, of course, speed distribution, so important for safety, travel time comparisons, and starting to look back at trend analysis, specifically for traffic stats. So really our speed product, origin destination, great for demand analysis, taking a look at route choices and geomarketing as well. And of course, the use case for junction analytics, of course, Brent with Miovision doing some cool stuff with the Mateo agent, but looking at queue lengths, points of delay along an approach, stops, split failures, other types of analysis that can be done on signal performance. So with all this said, we are starting to see how AI and our own internal use of AI can start to externalize to our partners like Miovision. And this can be rather different pieces of the puzzle in these different use cases. So we have vast array of data. TomTom has a vast array of data, and we really want to get this data into the hands of our partners to help solve those problems which really need a multi-source or multiple data solution. And that's what we're starting with this year and have started with Miovision. So what I will show you here is our the TomTom Traffic Command Center. And this is just a very lightweight demonstration of one of our products called Area Analytics. And what we've done is we've integrated that via the TomTom MCP into an LLM. So this is very easy, simple communication between the two services to call back the data that's built and maintained by TomTom. So what we like to demonstrate here is how easy and fast it can be with MCP to pull in TomTom data into an LLM or any other AI system that you are developing. At the same time, we can start to see the data that's coming straight back in from area analytics and start to see if it would be really cool if it restarted. There we go. Start to see some of the logic that the LLM is putting on top, or at least any other type of logic that maybe Brent will talk about. What other logic can go on top of the data that's coming back from TomTom, for example, and what insights or extrapolation can happen very quickly with this type of AI system. What has been taking traditionally a long time, some minutes to hours to days, big analyses, suddenly get a lot quicker. And I think that's one of the big interesting points that I think Brent will talk about a little bit as well, is how fast this can all get. So that's it from me for now. I appreciate you joining us today, and I'm going to hand over to Brent Rogerson of Miovision to take you through some awesome stuff that they're doing on their side. So with that, I will finish up wherever you are, Brent.
Hello, I am here now.
Let me just, of course, stop sharing. Of course, I hardly ever use Zoom. Thanks a lot.
Thank you so much. Let me just share my screen. There we go. Okay, great. Well, thank you everyone for joining today, and thank you for having me on this webinar. I'm gonna kind of go through how Miovision thinks about AI at the intersection and AI-driven intersection, as well as some of the ITS technologies that we're leveraging today, and kind of expand on some of the points that you heard earlier there around how AI is effectively accelerating a lot of the activities that can now occur on these large data sets. So with that said, my name is Brent Rogerson. I lead our solutions engineering team. I focus a lot on the technical architectures of our public agencies that we work with, integrating and maximizing the ecosystems uh, that currently exist, and then layering on intelligence on top of it, effectively trying to build towards that smart city goal of maximizing data sets. This often leads to really fun product innovations and industry conversations around where we can go with technology today, and also where we're headed in the future, which is all really exciting. So just a little bit about Miovision. If you're not familiar with us, I'll kind of do a little bit of an overview just to cover that. Miovision is a global leader in traffic data. I'm in the Kitchener, Canada office, just outside of Toronto, so not too far from there. And this is where the company started. It's been a development hub of Canada, and we've been growing for quite some time. We also have a US-based office just in Atlanta, Georgia, where there's another tech hub, a tech community where we can maximize our impact in the US-based market. And you can tell we also have a lot of sales outposts where we have our community members all over North America. We also have our office over in Cologne, Germany, where we're maximizing the number of countries we support and the number of cities worldwide, as well as our development hub in Belgrade, Serbia, where we're maximizing some of the tech community and the expertise that group brings towards us, allowing us to be hyper efficient in how we develop our products and our focuses. So Miovision is worldwide, and we're developing really rapidly. So our history, so Miovision's been developing technology for about 20 years now, just past our 20-year anniversary, but we actually focused a lot initially on AI and video-based technologies. We recognize that detection and sensors at the intersection at the very beginning of our journey was critical to producing high-quality data. We actually originally focused on a portable camera that you may have heard of. It's called the Scout. It's been deployed in over 68 countries today, and is providing a significant percentage of the turning movement counts that are produced worldwide today as well. It's become one of the leading uses of video-based analytics in the market. From that technology, what it actually allowed us to do is develop a very robust permanent set of devices, or permanent set of analytics that can be hosted on a device at the edge of an intersection. This is our detection and count stations that you can kind of see is kind of spread globally, or spread at least nationally in the North American market there. And we have about 15,000 sensors deployed so far across the North American market. But this device that we actually deployed doing real-time analytics is actually constructed very similar to like an iPhone, where you can deploy additional applications and you can deploy other strategies all remotely through the device, and minimizes the need for hardware at the intersection and maximizes the value of investments that agencies are making. So this has allowed us to deploy adaptive type technologies, performance-based data sets, and even connected vehicle architectures. What's become even more exciting is the community around us that is allowing us to maximize the value through our partners that are globally, our infrastructure partners like AWS and TELUS Canada, and many other major technology partner integrations like the TomTom integration that we're talking about here today, that really maximize the uses of data. Miovision One is our platform. So this is our cloud-based platform that actually aggregates a lot of these applications together. It is viewed as an operational platform or advanced traffic management system where you can effectively operate a lot of different applications. So we have our video-based detection and studies and counts in this platform, but as well as the intersection monitoring, so live streams of the infrastructure, including the traffic controllers and signal telemetry. We also have our performance-based analytics that we're going to talk a little bit more about here, because when you have large nodes and large sets of data sets, you produce a really granular set of performance around the intersection, and allows us to build towards other applications around safety and connecting vehicles into these data sets so that we can continue to grow this ecosystem. Think about Miovision One as almost like an integrated ecosystem of applications that can be used as from a public agency perspective to actually maximize that use of data. So our main customers with that in mind are actually the traffic department, the Department of Transportations that would leverage this data set. However, with that said, they have peripheral services and support around a public agency. So you have your traffic department that's trying to optimize your network. You have emergency services like the fire department that are trying to route their way through the network to get to emergency situations. There's transit agencies that are trying to optimize their routes and make sure people are trying to get where they're trying to go. And then you have freight operators that are trying to move goods in and out of cities. You have the public groups that are trying to create healthy communities where they're trying to grow pedestrian and bike safety programs. So all of these different types of users interact with our platform today. So we have developed an ecosystem of data sets, allowing them to interact with the data that's relevant to them, but also create the operational perspectives where decisions can be made or optimizations can be made without impacting other groups, or at least positively creating outcomes on other groups without having any negative impact. So all of the sum of the parts typically drives better value and better investment. So as I mentioned, Miovision is rooted in AI against video detection. This is kind of where we started. And we started with machine learning in mind. So we built our entire platform around the idea of taking in information, refining the output, and continuing that cycle. So through this process of deploying our cameras, deploying our both portable and permanent detection cameras, we created a continuous loop of high fidelity data sets and became the industry leading object detection provider for traffic agencies today. And so you can see here the quality of the video, the quality of the detection on the right, and the ability to identify all the different road users that are creating demand at our intersections. We can track their movements. We can track their classification, meaning car, truck, bike, pedestrians, buses, whatever it may be, and understand the movements that they're making, which lanes that they're in, the behaviors that are occurring at the intersection. And just as a disclaimer, we don't actually collect any personal identifiable information. This is traffic data that we're focusing on. Cameras are the best tool to achieve that with. But be reassured that this is solely in the focus of improvement to optimization and safety. And we are creating a very robust set of analysis around these classifications, which then also allow us to overlay that with the signal operation itself. So the high resolution data sets that are actually being produced from the combination of detection and signal status can allow us to understand performance of an intersection. And performance-based data is how we actually understand how to optimize. So we rooted our process of development in learning the environments, learning our objects that we're trying to optimize, what is the demand, and then how do we start tackling improvements from there. So AI has been a big part of our history and how it's being applied at the roadside, and now it's just starting to scale up into the platform. So kind of like to go one step further on that concept, really understanding how to teach a system is what a lot of us think about with AI. So you use a machine learning process to gather in information, to gather in raw data sources, but then you have to create a way for it to make decisions from. So you have to create baselines of decision-making criteria, like what is a car, what is the size, what are the windshields, what are the wheels. All of these are attributes that an AI tool can actually use to make decisions from. So this looks like a car, this looks like a bus. And then through continuous iteration of that process, effectively what you're doing is you're generating a continuous learning management system. And this AI application allows us to question the data, it allows us to improve the data, and also create some auditability of the data in a way that traffic agencies can get really comfortable with its application. And so we did this between an edge-based device as well as a platform system that allows you to interact with all of the data that it's producing. So with that in mind, intersection performance data is produced at large volumes today. So we call these automated traffic signal performance measures. And there are lots of different charts that we could get into, but some of the main ones that you think about are traffic volumes, total delay that are occurring by movements, there are vehicle delays, there are arrival metrics, there are pedestrian compliance, red light running type data. There's all the behaviors you can think around the intersection that can now be produced. However, a lot of agencies tend to run into this great idea of having all this data to make decisions from, but they do find it a bit overwhelming. It is a lot of data that we're producing. And in a survey that we did, about 78% of those respondents expressed that while these performance measures are very useful, it's actually really difficult to use, or they require just too much time to interact with these data sets. And that brings us to some of the challenges that we've learned in the public sector and where we believe AI can really help. What we've learned over the years in interacting with a lot of these public agencies is that there's kind of three key challenges that constantly occur. And this isn't necessarily unique to a region. This is something that we see commonly across the industry. It is very common for the traffic agencies to be very under-resourced. They're small groups. They're trying to accomplish big things, anywhere between optimizing a traffic signal, optimizing emergency routes, helping with transit operations, dealing with citizen complaints. And it's very common for any city to have somewhere in the range of 500 to 1,000 open complaints at any given time, which is a significant amount of responding that they need to do and resolution that they need to keep up with, and even just validating if any of those are actually complaints that they need to resolve. But effectively, that's a small team. They often have a various set of tools that they can leverage, but they're often fragmented systems. I often refer to this part of the problem as the 6-monitor problem. And what that means is you often go into a traffic operations center and you will see individuals sitting in front of 6 monitors trying to aggregate information from a series of different siloed systems to really understand where a problem is or validate a problem exists, and then construct an analysis. And that's where this manual analysis effect really comes from. It's a massive raw amount of data from different sources, resulting in a lot of manual heavy effort to create actionable intelligence. And so these three key challenges are where AI can really help accelerate and help this industry. And that's why AI for traffic is almost perfect. It's the perfect time. We're right at a moment where the data exists, and now it's about maximizing its effectiveness. We have built that data foundation with high quality data. We understand a lot of the use cases, the day-to-day traffic engineering workflows that we're trying to solve. And we're trying to apply tools to maximize the traffic agency. Think almost effectively giving these departments and these traffic management centers superpowers. How can we apply AI to allow them to accomplish exponential outcomes through bridging ground truth data with sensors to network level experience and probe data that you've heard about so far today. So the importance of unified data sources to these groups is critical. So traditionally, you have these two different data sets that do exist, that are available, but they need to be considered together. So you have a ground truth set of data around physical intersection sensors, providing that high fidelity, sometimes video-based detection quality data, but it's localized to a single intersection. Then you have the vehicle experience that actually looks at the broader experience of the journey. So the travel times, the speed, the origin destination that you heard earlier. A lot of times, these exist in two different data sets or two different platforms, and they've historically had to be merged manually to make the right decision. Think if you're going to change a particular issue at one intersection, what is going to be the outcome at the next intersection? Or if I make a modification at intersection 1, what happens to intersection 2? and make sure that we holistically approach that problem. So with the partnership between Miovision and TomTom, we have really unified these data sets. We're looking at both intersection to network level scenarios, so using probe level data to identify those hotspots, to look at where congestion is occurring, and then use the intersection level data to maximize where do we need to look at, where are the cues, which movements are we talking about, and then add a Gen AI traffic agent to help you navigate all these data sets together. This really creates that scalable monitoring scenario that traffic agencies desperately need. So you heard a little bit about this already, but the TomTom MCP is effectively the standardized communication layer that allows our Miovision Gen AI traffic agent that we call Mateo to interact with the data that TomTom produces at a network level. It's basically a bridge between both of our systems. And then add a conversational layer where the Miovision AI agent can actually, through a conversational prompt, ask both layers at the same time in a sense of getting the right response, get the right context, get the right perspective of the actual problem that's happening at intersection, and start working ahead of the traffic agency on the problem, effectively creating a larger ecosystem. As you kind of saw in the earlier presentation, a lot of the, not every intersection will even have the same amount of sensors. So where you don't have sensors, or where you do have sensors, you can now get a equivalent amount of value to maximize the view of the entire network. Where you don't have high quality video based detection sensors, you can now leverage probe level data to get very similar data where you can make the same decisions from, and then you merge the two data sets together through the MCP layer and through the large language models, where you can really use conversational approaches to this. So how AI can solve traffic problems, and we'll unpack this a little bit here. So Miovision's Gen AI traffic agent is really that force multiplier. This is our Miovision Mateo. It is looking at all of those different data sources, all of those different applications that Mio produces, but it also has access to all of the data sources and context that TomTom has. And this allows it to be context aware from every prompt and every explanation that it gives. It doesn't just look at the single raw piece of data to answer your question. It looks at the holistic view of the challenge, effectively creating an automated first pass of investigation. The first step of every citizen complaint or traffic problem is investigated, validated. Is it actually a thing that is happening? And what Mateo does is connect all these different data sources and provide a first pass investigation to the issue that is being raised, to allow the staff to effectively have those superpowers and go exponentially faster to solve them. So what that kind of looks like is a conversational analytic would be, instead of trying to collect all of the different data sources and the different counts or the different views of every intersection, you can simply ask Mateo or the Gen AI tool, how did the bridge closure in downtown Edmonton affect spillback on 104 compared to the TomTom baseline? So what this would produce for you is a synthesized report, manual, no need for manual dashboard creation. It immediately translates your natural language into a deep insight around the actual challenge across the network, not just a single intersection data report, but a holistic report on what is happening at the intersection and a historical baseline against what has happened over time. Is this a normal way that it's what the fallout has been from a lane closure or an intersection closure or a bridge closure, and then compare all these scenarios over time to the historical data sets. Just by asking the question, you'll get what you're looking for almost instantly or in seconds, and allow you to get to the root of the problem much faster. So what this actually looks like, I know I haven't really been, I've been explaining it, but not necessarily showing it. So Miovision 1 with Mateo and TomTom together, this is the view of our platform. So Miovision 1 is a map-based tool set that allows us to overlay our data set on the map, and it's a unified management hub of the existing data sources, whether that be from detection, video streaming, our mobility reports, think like counts, classifications, all those different things, our safety and performance measures, all of those get aggregated together. TomTom MCP allows us to interface with the travel time, the speeds, and the overall experience of the road, and then use Mateo, our AI-powered conversational agent, to actually analyze that question. So in the example here on the right, this is a downtown area where it's very dense urban environment, and the question was asked, what was congestion like on Thanksgiving and Black Friday in 2025? It starts working through that analysis on each day. What are the average speeds? What are the congestion in terms of time? What are the average travel times that we're seeing? And break it down from each one of the days and produce a set of information leading to a set of recommendations. So I'll let this kind of play back through for the other half of it. So it starts working through the analysis. It looks through an approx polygon, so it draws like where it thinks you're trying to talk about. It does some comparison between different of the days. What is the peak hours it's looking for? What are the root causes of this? A little explanation. And then ultimately, what is a recommendation of what you should do next? And this really guides a user to start looking deeper into the problem or start looking at the right parts of the data set. There's a little bit of a peripheral benefit from this type of operation, which is new staff kind of coming on board and new staff trying to understand what is happening in the city, what are the root causes of things that seem normal to all of us around congestion, around a massive shopping type day, could be new or foreign to any new staff coming into the mix. And by building up the context and the full picture of the data set can really help new employees adopt technology, can really help with the educational curves, and it can really help the scalability of any traffic agency that's leveraging the data set. This effectively streamlines the find and fix workflow. A lot of times, these are separated systems or the data sets need to be gathered, and sometimes you need to even go sit at the intersection to start solving problems. By moving into a streamlined find and fix workflow, you can detect network-wide hotspots or validate citizen complaints with TomTom probe data. You can diagnose the problem through queries with Mateo in the Miovision performance data with split failures and safety applications and count data. You can then determine a countermeasure and deploy that countermeasure either through signal timing or hardware fixes or whatever is necessary to resolve the problem, and then use the same data layers to then validate, did the network improve? Did you see congestion minimize? Were those improvements valid? And then you can report back to the citizen in a much more streamlined way. There's obviously even more opportunity to steer into ticket management and citizen data perspective so that citizens can see the outcome of these reports in better ways. But we're going to continue to work with our traffic agencies to evolve the data to be ready from that kind of perspective. But it still gives the traffic agencies the ability to respond to the citizens in a much faster way. So just to wrap up, a few different takeaways that I hope our conversation here kind of sparked inspiration around. But scalable coverage. So this is where you can interact effectively create a virtual infrastructure where you're layering on probe level data where you don't have sensors, where you don't have any data sources from. You have a probe level data view of the virtual infrastructure. You can then unify that data intelligence with the intersection level data. So where you do have sensors and you do have other data sources, you can unify the intelligence and the perspective, and then you can simplify your interaction with that data set through basic conversational prompts and take very complex, challenging questions into very quick, responsive data sets and recommendations of where to go from there, effectively streamlining that workflow. So thank you very much for listening. I hope that was inspiring and informative. If you would like some more information, please find us at miovision.com. I'm very excited for what the future brings with AI and all the different tool applications that we're thinking about and talking about. So thank you very much. And maybe I will invite Aaron to join us back here, and we'll see what we do next.
Thanks, Kristina, and thanks, Brent. And as we transition from our presentations into the Q&A, let's take a quick look at our poll results from earlier. Looks like we have the bulk of our attendees today, our local government, state government, but we have a good representation from industry and even a few from academia and other, primarily from the United States, it looks like today. So thank you all for attending. And we heard a lot today. We heard some practical AI applications of ITS. We heard about the MCP server, the maps, the APIs, operational data for predictive operations, which is exciting to me, moving from reactive to proactive. Uh, Talked about congestion management, junction optimization, incident response, scalable, data ready, moving from data to decision, all very important, I think, as we look forward in this industry. And then, of course, case studies where it's really being used, examples, and implementation roadmaps from that. So as we move into the Q&A, and again, as a reminder, you can enter your questions in the Q&A box along the bottom of your screen there. I'm seeing some questions come in already, so let's just jump right into it. And I think the first question from Tim is one that maybe has a broader application that can answer this as well, but I know a lot of people are concerned about data privacy, data personally identifiable information, all kinds of different dimensions to the anytime you're collecting data in a public setting. Can either of you shed some light on like how long do you need to hang on to this data for it to be usable in these tools and solutions?
From TomTom's perspective, everything we do is privacy first, being based in Europe and headquartered in the Netherlands. We have very strict rules to follow. Nothing is personally identifiable that we send externally out to any customer. Everything is aggregated in a way that is safe or skewed to make this usable and safe to use from the end user's perspective.
Excellent. Anything to add there, Brent?
Yeah, what I'll add from a Miovision perspective, because we do produce a lot of trend level data. So very true on the security side. We don't store any personal identifiable information. The level of information we capture is queue lengths. It would be did a car go left? Was it a bike or truck? So that type of information and volume counts. So there's two layers to the answer here. One is video records, and video records are actually stored at the edge, and they overwrite every 14 days. So from a video perspective, the storage is very minimal, and it's not stored in perpetually in any way. So that's one element. In terms of data, we actually store the data sources as long as the agency wants, but the agency owns the data. It's their data to leverage and use. So we follow their data storage policies, whether that be 1 year, 5 years, 7 years, whatever the agency prefers is the way we follow data storage and ensure we follow those policies.
Yeah, I think that's great. Empowering the users to make those determinations around governance and privacy, not handing down some policy that's really being driven by technology. So I think that's a great way to look at it. I see. I'm going to combine a couple questions here in the interest of time, but there's some questions coming in about the TomTom MCP server available for internal tools, along with Mateo's solution using internally developed LLMs versus can I deploy my own LLM with that? Maybe I'm not a Chat GPT shop, a Claude, or I'm a Claude shop, et cetera. And I hear this coming up more and more, so I think it's a well-positioned question because when it comes to some of these AI tools, I look at it, maybe you're Amazon, maybe you're a Microsoft, maybe you're a Google shop on cloud, and, solutions work with these different things. Are we going to see that same kind of approach around these tools that are being developed and the MCPs that are being developed for solutions in ITS?
I think from TomTom's perspective, we've We are, especially with our traffic data and location analytics product suite, we try and be as cross platform as possible, where cross map as possible. That's probably the best way to put it. So I think we'll have the same approach as we'll try and be where our customers need us to be.
Perfect.
Yeah, very similar. We do base our LLM and GPT-5, which is a lot of what ChatGPT leverages as well. So it is a common LLM that we are using on the call it the academic application of language and the understanding of the world. Using GPT-5 really lets us connect those dots and become scalable. But with that said, that's where we started, and making it interchangeable as the perspectives evolve and the preferences evolve as well. We're going to continue to be an open and flexible for our customers and our agencies and our partners, of course.
Fantastic. We had another question come in from an attendee around the Mateo solution. So this one might be for you, Brent, around the skewness readings. Is there something above 100% on the subject value? But I think more broadly, just looking at this, and again, tying it into some other concepts in the interest of time, I hear a lot of end users come back and talk about audit validation. I know you touched on those things a little bit in your respective presentations, but I think whether it's the provenance of the data, we're seeing all these proliferation of models coming out and not an equal proliferation of understanding in what's going into the models sometimes. So how are we handling that in ITS solutions for transparency? I think you mentioned, Brent, but reproducibility. Am I always going to get the same answer given the same inputs? Given the nature of dynamic data, maybe that's not the way they look at it. But if you could each offer just a few thoughts on that.
I could go first. Yeah, it's a good question because we have been experiencing this a lot. If you ask the same question, you can get multiple answers, especially as data evolves, and data sources improve as well. So where you had a response that maybe is based in low fidelity initially, if you increased your data or increase the fidelity, the improvement of the response will actually go along with that. So really understanding the quality of the prompt and the quality of the data sources becomes critical to actually measuring the output that we're getting. And we've had to come up with ways to baseline it over time. And so we've had to look at different types of words being used as well in the prompt and how that changes the outcome. And now we're trying to almost do prompt engineering on ourselves and learn a lot more about how you interface with it, but then also validate the information that's coming out of that prompt on the other end. So validate it against multiple sources. So if we only have one source of data, it gets a little bit hard to validate the accuracy of that response. So then having partners like TomTom, where you can have multiple sources of information, allows you to validate yourself against other sources in a way that if initially when I asked the question, did it produce a response only in Miovision's data, or did it produce the response in multiple data sources and surface that in the prompt itself or in the response itself? So what we do in the Mateo experience is you can actually see its thinking. You can expand its thinking, and it'll show you what are the data sources it used to answer that question. We are early in this AI adventure, which means we're still learning quite a bit about how it reacts to different things, but we've created some baselines to measure against that, and I think that's been really helpful.
Great. Anything to add, Kristina?
Yeah, I think as we're acting here as more of a data provider, just being very clear with our partners on what data is coming in and our ways of measuring our quality and being very clear on that and transparent, that helps. And also having a very good connection with our partners. We really work on that, especially in a technology like this, which is changing very quickly. I think that's a big benefit that we have, is working very closely together to make sure we have accuracy, reliability together, and for the use case is very important. I think that's going to be more important going forward as well.
Great, thank you. Well, we're coming to a close here, so I have one final question. If an attendee is like, I'm ready to go, I want to do this. Like, what's the next steps that they need to take? Do they need to upskill people on their team before they can even get started? What realistically can they do in-house versus needing a partner along with them to implement this? So give our audience a sense of where to go from here now that they've learned about AI and ITS.
Brent, please.
Sure, I'll give that a start. So, I mean, generally, we work with almost every city today in some way. But my recommendation to the listeners or to any users is just start. We can meet, we can talk through where that starting point is, and just getting access to the initial data sets and start working your way through. It's certainly not as scary as it actually is once you get into it. It's really fun. The education curve is exciting in the sense that you can test the responses, you can ask as many things as you want to see what happens, and then validate it against your existing workflows. So look at what data it's producing, what are you doing today, and how can you migrate your operations into a different workflow. But starting is the key. So like start with a single area of your city, or start with a very simple side of the problem and see how does AI actually tackle that. You can start that from a Miovision perspective, or obviously through the partner with TomTom, and start at either the network level or at an intersection level. But either way, starting is always exciting. So
Thank you. Any final thoughts there, Kristina?
This is why we work so closely with our partners, and Brent and Miovision. You guys are local, you're there, you know best, and we're there to support from our perspective. But and you can really help to solve the problems and set it all up. So yeah, very happy to work with our partner network.
Well, amazingly, we're already out of time. So again, I'd like to thank our webinar series sponsor, TomTom, for making this opportunity available today. And then also thank our speakers, Kristina and Brent from TomTom and Miovision, respectively. Thank you all and look forward to the next webinar.